In question 14, we are given that a prime number between 300 and 450 is chosen at random. And we are given this table that shows the probability that the number lies in different ages. So for example, we can see from the table that the probability that the prime number n is greater than or equal to 300, but strictly less than 330, is 0.16. In part A, we are asked to work out the value of x. Well, we are given all the probabilities on the right-hand side, and remember, the probabilities must add up to 1. How do we know that they add up to 1? Well, the prime number is between 300 and 450, and the table covers all possible ranges between 300 and 450. Therefore, the probability that the prime number is between 300 and 450 is obviously 1, because we are told that it's between 300 and 450. So all we need to do is add up all the probabilities, and these should equal 1. So we need to do 0.16 plus 0.24 plus x plus 0.16 plus 0.24. And we know, because these are probabilities, they add to 1. Okay, let's combine some of these. Well, the 0.6 plus another 0.6, that's going to give us 0.32. And then we're adding that to 0.24 and another 0.24. Well, that's a 0.48. And then we're adding our x, and that equals 1. If we add these two together again a little further, we're going to get 0.8 plus x is 1. Rearranging, taking away 0.8 from both sides, we're going to get that x equals 1 minus 0.8, which is 0.2. So the probability that n is greater than or equal to 360, but strictly less than 390, is 0.2, or 20%. And that is the answer to part A. In part B, we are asked to work out the probability that the prime number is greater than 390. So we want the probability that n, our prime number, is greater than 390. And this is the notation I tend to use. So I have a p open brackets, so the p means probability, and then the thing in brackets means the thing I would like to know the probability of. So I'm looking for the probability that n is greater than 390. Well, we are going to have to use the table for this. We know that n is between 300 and 450. So if we want the probability that n is bigger than 390, this is essentially the probability that n is bigger than 390 and less than 450. Well, we can see from the last two rows of the table that the probability that n lies between 390 and 420 is 0.16. But we know it could be all the way up to 450. So we need to add to that the probability that n could be between 420 and 450. So we need to add to that 0.24. And if we do that, we get 0.4. So the probability that n is bigger than 390 is 0.4, or 40%. In part C, we are told that there are 4 prime numbers between 300 and 330. And the question asks us how many prime numbers are there between 300 and 450. Well, if we go back to our table, we can see that the probability that n is between 300 and 330 is 0.16. So let's let t equal total number of primes between 300 and 450. Now we are told that there are exactly 4 that lie between 300 and 330. The probability that the prime number lies between 300 and 330 is 0.16. So 0.16 times the total amount of primes in that range must give us 4, because that's what we're told. But we want t, we want the total number of primes between 300 and 450. So we just need to divide both sides of that equation by 0.16. So t, the total number of primes, is 4 divided by 0.16, which is 4 divided by 0.16. And the way I'm going to do this is treat that as a fraction. So that's 4 divided by, well, 0.16 is 16 100ths. And if we divide by a fraction, we multiply by its reciprocal. So that's the same as 4 multiplied by 100 over 16. Which is, I'm going to do a bit of cross-cancelling here. So we've got 4 and a 16, they cancel, so that becomes a 1. 16 divided by 4 gives us 4. So we're given 100 over 4, which is 25. Feel free to cancel that further. We could have said that's the same as 50 divided by 2, which is 25 over 1, to get the answer of 25.